All right, welcome to this one. I'll be talking about Kubernetes, and I would like to start with what I've so far done and how I've configured my application to use Kubernetes locally. All right, so I'll start by accessing it here. So I've deployed using a service, and if I go to admin, so everything works pretty well. Can add a new record. All right, looks good. So and also this is all right. So mainly this is it. So I will come back to my configuration and show the configuration that I have. Just I will go through briefly, and then we will get into the details. All right. So I have my two files here. So this is a Django backend deployment. So I use Graphene, so that's why I really named this file like this, but that doesn't really matter. And then I have my Postgres deployment. So inside this file, I have the deployment, as we can see here, and then I have a service. That's what I have in this Graphene deployment. And then I have in my Postgres database deployment, I have a number of things. I have a secret, I have a persistent volume, then persistent volume claim, then I have a deployment, and then I have a service. And then I also have, so these are the two YAML files that I have. And then I also have a Docker file from which my backend container is created. Yeah, so this is it. This is what I have for the configuration, and as we can see, this is deployed using a service. And if I come here and say CTL service, oh sorry, this should be Minikube. So you can see this is my URL, and that's how I'm able to access this. So I will now go through to see how I was able to create this. So we see how I was able to create this, and also to highlight the concepts and some details about Kubernetes. All right, so I thought I would first show how it works, how I was able to configure it to completeness, and then we will go through everything, how I came up with it, and the concepts behind everything that I did. All right, and then after I will delete all the configuration and run it again so that we see how it all works out. All right, so what is Kubernetes? So I will first start by going into the docs. I linked this to the docs, and the docs simply tell us that Kubernetes is a portable, extensible open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. Now, for us to be able to understand what this is, what Kubernetes is, let's go back in time. And I try to reference the documentation as much as possible so that if anyone is starting with Kubernetes, they will be able to start naturally with the available documentation. So let's start by looking at the traditional deployment. Now, traditionally, if people wanted to deploy apps, most organizations or most companies or individuals would have a server which has its operating system like Linux or Windows or whatever, and then they would deploy the apps directly to that computer or that server. So if they had 4 apps, they would deploy app 1, app 2, and configure each app on that same server. Or it could be different servers, but each server could have one app. But the thing here was that an an app was deployed to a physical server and um, configured there. Now, the problem with this is that there was no way to define resource boundaries for applications in a physical server, and this caused allocation issues. So if I had app A and app B and app C, there's no way to say app A should consume this, app B should consume this, and app C should consume this. Yeah, and also another problem was that if if this computer got a problem or crashed, a hard disk crashed or whatever, something went wrong, it would be very difficult, to recover, and one would have to set up another computer or another server and manually do the configuration. And for some config that was very difficult, it is time consuming. It would be time consuming to set up such. So from that level, we went to another era where people and organizations were using virtualized deployment. So this is where apps would be configured and run on virtual machines. And so we would have, let's say, a server with its operating system and have a hypervisor on top of that. And then we would have virtual machines, multiple virtual machines, or one or multiple virtual machines on top of the hypervisor. And so each virtual machine had an operating system. And so if I wanted, one could actually deploy 2 apps on one virtual machine and deploy 2 other apps on one virtual machine. Literally, these virtual machines would work as normal computers, but the advantage they had over this is you can actually allocate resources to a virtual machine, which you wouldn't do here in the traditional deployment. And there was like separation of concerns. You could you could that there's more security, here than we had here in the first place. But also, these virtual machines are not lightweight, and they are a bit heavy. Yeah, they are actually heavy, though they were a better approach compared to the first one. So now from the virtualized deployment, we went to container deployment. And this is the modern now way of deploying. With this, we have a hardware operating system. Now, instead of a hypervisor, we have a container runtime. Yeah, and the container runtime allows for, let's say, one to create multiple containers. So each container can have an application. Yeah, deployed. So it will have like sort of its own system files and sort, but it is totally separated from one container would be totally separated from another container. They cannot access each other unless there is like a network or communication setup between them. Now, the advantage this has over the virtualized one is this one is lightweight, and we are basically separating processes, while here it's on the virtualized deployment, we are separating operating systems. Yeah, and here we are separating just processes, but everything still underneath runs on the same operating system. So So with a container, one can, let's say, be able to run a container using technologies like Docker, where you create an image and then from that create your container. But if, let's say, I had my full application which has the back end and database and then front end, and I want to run maybe 3 containers, I can start these containers and everything will work well, but there are going to be issues like if a container goes down for some reason, uh, I need to inspect manually and then go and start it, and that can cause downtime. If I had multiple containers, I would have, let's say, monitoring them would be somewhat difficult. I wouldn't know which one has gone down, which one is running and which one is not, apart from if I checked manually. And this is where a technology like Kubernetes comes in to actually do orchestration or container management. So Kubernetes basically does orchestration or container management. It helps with Kubernetes. It can quickly discover if one container went down. It can know this container went down, and there can be a replacement for that, and one doesn't have to monitor manually. Kubernetes will take care of that. All right. So why do we need Kubernetes? And that's what I just basically said. Containers are a good way to bundle your application, but in a production environment, you need to manage containers that run applications and ensure there is no downtime. So if we don't have something that manages that for us, you could be there sleeping and a container goes down for whatever reason, and there would be downtime. But with Kubernetes, it helps us to ensure there is no downtime. Yeah. So for example, if a container goes down, another container needs to start. Yeah. So if you were not monitoring it with your physical eyes, it means until you discover that, oh, everything has gone off, then you go and start the application. So wouldn't it be easier, to have like a system that handles, starting of new containers when the old ones go down? So that's what Kubernetes is for. Now, so one other thing is that Kubernetes provides you with a framework to run distributed systems resiliently, and that's why it is now being adopted by the entire industry. Yeah. All right. So now let's look at Kubernetes Cluster. Now, when we talk about Kubernetes, now you've probably understood that, yeah, it is very important and it's a good technology. But now we need to understand the specifics. Yeah. So for us to use Kubernetes, we need a Kubernetes cluster. We need a cluster. So what is a cluster? So a cluster is, simply like a group of nodes or a group of computers, that work together. That's really what I can call a cluster. And if you search for cluster meaning, we can see that it's a group of similar things, or it's a group of similar things. So a cluster in Kubernetes would be, or in computing would be a group of computers. Yeah. So when we talk about containers and all that, ultimately all these things would need to run on computers and on computers. So but in a certain way that doesn't doesn't have doesn't put these applications in a situation where they are dependent, or they are coupled to the computers. So they are like decoupled away from the computers, but of course they have to run on the computers. So a cluster is a group of computers that work together. Yeah. So these computers can be either physical computers or they can be virtual machines. Yeah. So that's what it is. So in this language of Kubernetes, we call them nodes. But basically, whenever we talk about nodes, we are talking about a computer or a virtual machine. So if you look at this cluster, it would have this cluster has like one, two, three computers or three virtual machines. Yeah. So now a cluster, Kubernetes cluster mainly consists of two parts. Now, we have a control pane that coordinates the cluster and the nodes that run the applications. So ultimately, each of these nodes, or whatever we call virtual machines, at the end of the day, they are computers. But there is one that acts as a master, or that acts as the computer that actually controls the others, and that's what we call the control pane. So whatever computer or computers are designated to be the master or the control pane, the master that controls the others is what we call the control pane. And then these other ones, the other nodes, we call them the worker nodes, and these are the ones that run the applications. Yeah. So each node, we will get into to look at the nodes and control pane in details, but that's mainly what it is. And if you want some information about these, I linked the documentation here. We can mainly see our Kubernetes cluster and read more about it. Yeah. All right. So this diagram shows a little bit in more detail the elements of a cluster. So what we see is we have a control pane, this, and a control pane, which we basically call the virtual machine or a computer that acts as a master that controls the others. And if you see, it has other components like etcd, schedule, control manager, and then the API server. And we see these other nodes. So we see each node has like a kubelet and also has some components. Okay. But as we can see from the diagram, there is control running from the API server to these nodes. Yeah. And then we see that if we have a cloud provider, they could be controlled through this cloud control manager. So these are the elements or the components of a cluster mainly, and we can get more information by reading about what each of these does. All right. For example, the API server is a component of Kubernetes control plane that exposes the Kubernetes API. All right. So we can get more information from the documentation. Now, let's go to the next thing. So the other question, one question could be, where do we deploy a cluster? So right now I'm running locally on my PC, and I showed that this is running, and it's being this is a service from the cluster. So one might be wondering, how do we deploy a cluster? So I'll make it very simple. Kubernetes cluster can be deployed to either physical or virtual machines. As I said, physical computers or virtual machines are what make up a cluster. Yeah, but locally we can create a cluster using Minikube. Now, Minikube is a lightweight Kubernetes implementation that basically creates a virtual machine on our local computer, and then deploys a simple cluster, containing only one node. So like where I am at right now on my computer, Minikube creates a virtual machine that now and then creates and deploys a cluster. And then since I'm on my computer, I basically have one node. It's going to create, I have one computer, so it's going to have a cluster containing one node. Yeah. Now, Minikube as an application is available for Linux, macOS, and other and Windows systems. And if one wants to check out Minikube, there is a link to documentation. And in one statement, you see the documentation says that Minikube is local Kubernetes, focusing on making it easy to learn and deploy and develop for Kubernetes. So once one installs it, there is an installation procedure. By running Minikube start, it starts Minikube, it starts the cluster. Yeah. So basically that's what it is. Now, what about if we are not on our machine locally? Where do we deploy, a cluster if we are talking about like the cloud? So each cloud has like implementations that allow us to use clusters. So for example, like AWS has Amazon Elastic, Kubernetes service, and this is a way to start, run, and scale Kubernetes. So if I was working on Amazon from AWS, I would use EKS to have and use my cluster on AWS. But also each like the popular cloud platforms, also GCP has one called Google Kubernetes Engine, and it basically does the same thing, a simple way to automatically deploy, scale, and manage Kubernetes. And also Azure has one called Azure Kubernetes Service, and basically does the same thing. Yeah. So that's what it is. Locally, we use Kubernetes, but on cloud, we use whatever is provided by the cloud that we are using. All right. So how do we start the cluster locally? So I would just simply like pull out my terminal. This is already running the cluster. So we basically so if we say Minikube version, we can see the version of Minikube that is installed, and we start the cluster by saying Minikube start. Okay, that is how we do it. And we also have Minikube comes with a dashboard, that allows us to see all the cluster configuration and components within a browser. And as you can see here, I already run Minikube dashboard, and when you run this command, it basically if I can just stop it and run it again. So this is how it looks like. All right, this is how it looks like. So with this, I'm able to like check my deployments. I'm able to check my pods. I'm able to check services. I'm able to check secrets and other I'm able to check pods that are running. I'm able to check the details. So this kind of makes it easy for one to be able to check out the elements and even perform some operations, like I can delete or edit a deployment or something like that. So that's it. And then I can check kubectl version if I want. I can check kubectl version. So kubectl is how we interact with our cluster, and perform operations. Yeah. So when we install Minikube, also kubectl is installed, and we can check the version. And we can check the version here. So basically we can see the client and then the server version. Yeah. So that's it. Now we can also check our cluster details by executing this command, cluster info. Perfect. We see that our control pane is running on this, port, and core DNS is running at this. Yeah, so we are able to check information about about the cluster. Yeah, and we can also see the nodes, and basically we have one node, and it's the master and a control plane. So if we want, we can check we can see more information about this node by describing it. So we can see more information, and as we said, a node can be a virtual machine or a computer, and so since we are on this computer, we basically have one node, and these are the details. And as we can see on this, we see that it has Kubernetes, and they can show the Kubernetes version, and it has container runtime, and we can see that as well. And we are able to see other details like the Kube proxy version, yeah, and other details. Yeah, we are able to even see the resources. Yeah. So now let's talk more about the control pane, because we want to understand the cluster very well, and and how things are interconnected within the cluster. So we said that the control pane is responsible for managing the cluster. So as we can see here, the control pane, acts as a master node, and it's also a computer or a VM, and acts as a master node controlling the others, like we said earlier. So what is the use of control pane? So control panes manage the cluster and the nodes that are used to host the running applications. So in that role of management of the entire cluster and its nodes, it has components that allow it to do that. Like the Cloud Controller Manager, as I showed earlier, we can check out the components of that, and the role of each component. etcd, a key value store, the scheduler that allows for scheduling nodes, and the control manager. Yeah. So how does the control pane manage these other nodes? It does it through the API server. So think about a developer who is here and is executing his kubectl commands like we've been doing, or using the dashboard. So those commands are taken by the API server and sent, to the worker nodes. For each worker node has like a kubelet and container runtime, and we saw that the use of a kubelet basically is the one that enables communication between the node and the control pane, and so the commands sent by the API server are received by the kubelet and then sent to the container runtime. And then if we also want to use a proxy, we can basically access the node through a proxy. Yeah. And if we also wanted to access have like some control from, the cloud provider API, we can use it's also done by the control pane through the cloud controller manager. Yeah. Yeah. So our that is what a control pane does, and that it is what it is for. And just to have more insight on these components, we already saw that the API server basically sends, uh, allows us to exposes the Kubernetes API to allow us to send commands and control to the nodes. The etcd, which we saw here, it stores. This is the key value store that basically stores the information related to the cluster, in a key value format. Yeah. So that's its role. And now, let's see. The scheduler basically watches for newly created pods with no assigned node and selects a node for them to run on. So if we have new pods that have been created, pods are inside of a node. It allocates the worker nodes to the pods. So pods are supposed to be inside of a worker node, but that allocation of allocating pods to the worker node done by a scheduler. And the control manager, as we can see, is a component that runs controller processes. Yeah. So this other control is done by the control manager, and it controls the processes. So I got this. There's a link here where I borrowed this diagram. Yeah. So when you deploy applications on Kubernetes, you basically tell the control pane to start the application containers, and the control pane schedules the containers to run on the clusters nodes. Yeah. And the nodes communicate with the control pane using the Kubernetes API, which the control pane basically exposes. And end users can also use the Kubernetes API directly to interact with the cluster. Yeah. So that's a brief about the control pane. So now let's take now a deeper look into what nodes are. We have already talked about nodes, that these are virtual machines or computers. But what is actually inside these nodes? Let's look at these details. So as you can see here, I put a picture of a computer, or this screen, to show that literally this node is either a physical computer or a virtual machine. So that's what we should have in our minds. And this node has two processes. It has a kubelet and then a container runtime, like a Docker. So think about a computer which is going to be controlled by a master node, or what we call the control pane. So that it needs to have a way of receiving communication and knowing what to do with it, and that's what the Kubernetes service is for. So this allows communication between this node and the control pane. So when commands are sent, they come to the kubelet, and then they go down to the kubelet, channels them to and make sure they are doing what they are supposed to do. And then the container runtime, or the Docker runtime, allows us to be able to run the containers, on this node. But what we also see is that we have pods. So what is a pod? We will look at what a pod is, in the next slide. But it's like the smallest component or element of a cluster, and basically it is the one that acts as a wrapper to to the cluster, sorry, to the containers that are created. Otherwise, since the node is a computer, you would expect, let's say, containers to be running directly on a node. But that's not what happens. They run inside of a pod, and a pod can have one or multiple containers, as we'll see, but it also has other things like volumes, storage, and other things. Yeah. So basically, consider a node to be a worker machine, and it may be a VM or a physical machine, depending on the cluster. And one thing we know is that multiple pods can run on one node. So multiple pods can run on one computer, which is working as a node. All right. Um, all right. So let's go to the next. Now, we already talked about pods being inside of a node, but let's dig further and have some more information about these pods. Now, a pod is a group of one or more application containers. When we look at these pictures, we see that each pod has an IP address. So, for example, each pod that is created will have its own IP address, and then we'll have containers inside it. But we can have one or multiple containers inside a pod. So number one thing is that we have pods that run a single container, and then we have pods that run multiple containers. Yeah. So now what we need to understand is that when we create a deployment on Kubernetes, again, we will understand more what a deployment is, but it's basically a deployment is what creates the pods with containers inside them. Yeah. So when we create a deployment on Kubernetes, that deployment creates pods with containers inside them, as opposed to creating the containers directly. So every time we talk about containers, just know they exist inside the pods, and a pod acts as a wraps around them. Yeah. So each pod is tied to the node. We cannot have a pod that is not tied to a node. Otherwise, where would it be? Because uh, it has to exist somewhere on a computer, which is basically going to be our node or a virtual machine. So each pod is tied to a node where it is scheduled and remains there until termination. So this container that we are seeing here, unless it is deleted or terminated according to, or restarted according to the restart policy, it's going to be inside of here. And once it is killed and another one is spinned up, basically it could exist in any it could be taken to any node according to what the scheduler in the control pane decides. Yeah. And also what we need to know is that in case of node failure, if this virtual machine or physical computer that acts as our node fails, identical pods are scheduled on another node, on other available nodes in the cluster. So that is beautiful in that if I have my cluster that has 4 computers, in that computer A fails, everything in there is going to be recreated on another computer without my intervention, and that's where Kubernetes actually comes in, to help. If we are doing the traditional approach, if a computer fails, it has failed. But here it fails, it is whatever is on that PC is recreated, on another node. Yeah. So which is very powerful. Now, one thing we need to know is that ideally each pod is supposed to run one container. Even though it provides for running multiple containers, but it is recommended that each pod runs one container. unless we have a situation where we have like multiple containers and they depend on each other, or they are coupled in a way that we need to run them on one pod. But apart from that, the standard would be having one pod, one container. And even then, if we need to scale the pods, the containers, we can actually create like scale them and create like a replica set. So we don't really need to have multiple containers on one pod unless it is really, really called for. Otherwise, we can create multiple pods and have each pod having one container. Yeah. So that's it mainly. And if we are to have some more understanding into this node pod container situation, we have, let's say, this node. Okay, consider us having this node, and we have a pod there. We can have multiple pods, but consider this pod. Now, each pod has an IP address. Now, this IP address comes from the IP range that is available on the node. So consider this virtual machine or physical computer, which has a range of IPs. Now, the pods created inside of that node are going to be within the IP range that that node has. Yeah. So, for example, we have this virtual machine or computer, which is our node 2, and you can see that this pod that was created, it is within the IP range. So, that's again one way that one can know that this pod belongs to this node, because you can basically look at the IP address and know that it belongs to this node. So if we had the one, let's say 10.2.1. something, then we'll know that that belongs to node 1. And the containers created inside of a pod can expose different ports. So for example, this container one can export port 3 can expose port 3000, and this container too can expose port 9000, or all of them could be expose the same port. Yeah. But mainly a container would expose a different port. But again, this is a pod with two containers, and this is something that again we are discouraging, that it shouldn't be the case. We should have one pod containing one container. But in the event that we have two containers, each one can expose uh, its own port, and then it could be reached through that port. Now, if we want to see pods and their IP addresses, we could execute this command, kubectl get pod. By the way, this returns pods that are currently running, or that we currently have. But if we want to see the IP information, um, by adding that -o wide, we are able to see the IP addresses of our pods. So from here, I can know that um, I have two pods, and one has this IP and another one has this IP. And basically, you can actually see these belong to the same node because of the IP address. Yeah. All right. So if we take a look at some few commands that can allow us to interact or to see information about pod. So if I say kubectl get pods, that returns for me the pods that I currently have, and I can actually see more information about these pods by describing them. And this kind of describes both all the pods, but I might actually want to describe a particular pod. So I can pick this and say kubectl describe pod, boom. Then I put the pod name, and now I just get information about that pod. So for example, I can see it belongs to the node with this IP address, yeah, and then I can see when it was created, and I can see the label, I can see its IP address, I can see the container ID, and plus more information, yeah. Now, our that's it about that. Now, we can also see logs when a container runs. It basically anything that the application running on the container within the node, within the pod, anything that is sent to the standard output becomes like logs. So becomes logs. So we can check the logs. So I can say give me logs of this pod, and I can basically see this. This is actually a Django backend, pod. It contains a container that basically runs a Django app, and we can see these are logs, that show what has been happening, yeah, on the console of my terminal within that runs that application. So that's basically it. And now something we talked about earlier was that we can access a pod through a proxy, and how that can be done is I will just hit this. So I can come and expose my pod through a proxy. So I can come here and do something like kubectl proxy, boom. So this shows me that I actually now have access through a proxy. So all I need is to provide more information of the pod. And now that pod that I had, I will put its name here, yeah, and I'm accessing the pod through the API, so you can see that namespace is default pods, then pod name, and then struct proxy. And boom, this allows me to access the pod directly. So a proxy gives access to the pod directly. So I can add admin here, and boom, I'll be running. So of course, in production, you then want to really expose the pods directly, but this can allow me to, for example, interact or debug my application because I will have direct access, to the pod and to the container. And when I have access to the pod, I actually have access to the container. Yeah, and I don't need to even like specify anything. I have access to the pod, I have access to the container running within the pod. Yeah, so that's it here. All right, so there are other, few commands that we can learn about on how to interact with a pod. And so if I wanted to see environmental variables set, on a pod, uh, I can run kubectl execute, then I put name, and then I put dash dash env. By the way, previously we used to run commands like this, but now we have to put this double slash double dash. So these are environmental variables that are accessible through by the pod, by this pod. So it means that when I'm in this pod, these are all the environmental variables that I have access to. Yeah, pretty perfect. And also I can actually start a bash session within the pods container, and I can do that by executing this command interactive, then the pod name, then dash dash bash. So this gives me direct, I'm now on the I'm having a bash session with a container in this pod, and if I do this, I'm able to see my files and all that, and I can pretty much run anything here. I can run migrations. I can create a super user. So I can basically do anything I want here. Anything I really want, I can do. Yeah, migrations, make migrations. Anything of that sort. Yeah, I can even check if the application is running. Yeah, on this. So you know, that was it about the pods, and we will see them more into practice later on. All right. So now we will go to our deployments, and by the way, before I go to that, in my configuration, all right. So before we go to that, uh, in my deployment, but first, before we get to the deployment, let's first know what a deployment is. Yeah. Now, we learned that for us to create pods, that then are, you know, are, scheduled onto the nodes by our control pane. For us to create these pods, we use a deployment. So, what is a deployment? What is a deployment? So, for us to understand a deployment, we need to know that we need to create pods that ultimately have our containers. Yeah. Now, we create these through a deployment. Yeah. And if I am to show an example here for us to have proper understanding, now this is my deployment. Now, for me to create pods, I have this specification here, this specification. On this, I'm basically at this point, I'm specifying how my pods will be created. Yeah. And for example, I'm saying I want replicas, I want one. If I put two here, it means it will create uh, two similar pods, which will be in a replica set. I have like a rolling update. I have other information. I can even specify what the name of the container in that pod will be, from which image will it be created, what command should be run when the container starts, all that information. Yeah. So a deployment provides like a declarative way, for creating pods, and replica sets, and also updating these pods and replica sets. Yeah. So if we had to look at this diagram, which I basically took from this link, um, from this article, we see that a deployment will create, let's say, replica sets. So each replica set has so for example, here, this replica set has two nodes, this one has two nodes, this one has two nodes. So these would be like, so each replica set might have a number of pods or even one. So at the end of the day, these pods have to be sort of allocated or scheduled to run on nodes or our computer stroke virtual machines. And that is something done by the control pane. But basically here we are showing that ultimately this could go onto any node. So for example, this pod could go here on this node, this one would go here. It's not that all pods created by one deployment must go on a certain node, but they can be distributed to different nodes. Yeah. Uh, so one might be wondering, what are the use cases of a deployment? So we use them to create a deployment to roll out a replica set, like we have said. We can also use it to roll back to an earlier deployment version. So it's basically allows us to define how we want our pods and replica sets to look like. It may be creating new ones, changing information, you know, uh, cleaning up all the replica sets, uh, and all that. Yeah. So we can always create new deployments or update existing ones. Yeah. Yeah. So one thing we also need to know is that a Kubernetes deployment checks on the health of your pod and restarts the pod's container if it terminates. Yeah. So deployments are the recommended way to manage the creation and scaling of pods. So the next question would be, how do I create a deployment? This can be checked in the documentation. The documentation has everything about how to create a deployment and goes ahead to provide some good explanation on how that can be done. All right. So you know there's more info we can basically learn about deployments, and all right, so let's see more information about the deployments. So you can see more information on how to create a deployment and all that. But if you were to go through briefly, uh, so once you have a running Kubernetes cluster, you can deploy your containerized applications on top of it. Yeah. Now to do so, uh, we need to create a Kubernetes deployment configuration. Yeah. So a Kubernetes deployment configuration looks something like this. Uh, you know, we'll go through this file, but this is how it looks. Yeah. So this is like a configuration file that we create and then run. Yeah, now this deployment instructs Kubernetes how to create and update instances of the application. So all those instructions are basically put here. This is where you put let's say if let's say when a pod goes down, for example, like this rolling update, this it even talks about how um, when one is destroyed, how the other ones, if I have like 4 pods, it talks about the maximum number of pods that should die at a time, and then the ones that should be available at a time, and all those things. Yeah. So now once you've created a deployment, the Kubernetes Control Pane schedules the application instances included in that deployment to run on individual nodes in the cluster. Yeah. Again, this we see the role of the control pane coming into play. And now, once the application instances are created, a Kubernetes deployment controller continuously monitors those instances and to make sure that whatever we like, if we have pods, if let's say something happens, uh, the state of those pods should always be what we expect. And if anything changes, then the controller will take action. Now, if the node hosting an instance goes down or is deleted, the deployment controller replaces the instance with an instance of another node in a cluster. So if our computer on node goes down, if we have 4 nodes and one goes down, and let's say it is this node that was running our application, so the pods and that instance of that node will be created on another node, and that kind of provides a self-healing mechanism to address the failure, machine failure or maintenance. And this is one of the strongest benefits that we get from, Kubernetes. One can argue that they had a way to do that in the pre-orchestration world, like before Kubernetes. One can say, oh, we used to create our scripts and they would start the applications for us, you know. But these scripts could, yes, um, start applications, but if a machine failed, these scripts could not bring up the machine. If the machine crashed and failed and or went off, they couldn't uh, transfer, because you have a machine, it has failed. You could use a script to run the applications on the machine, but if a machine, for example, is struck by electricity and it burns, the motherboard burns, yeah, so how would you handle that? There's no recovery. So, but in this case, if one machine dies for whatever reason, is disconnected, dies or whatever, uh, then that instance can be recreated on another computer, and that is where you know that is the self-healing that we are talking about, and ability to have no downtime. Yeah. So by both creating your application instances and keeping them running across nodes, Kubernetes deployments provide a fundamentally different approach to application management, and that's what we see basically. Now, when creating a deployment, I mean, we could run a command in the terminal, Kubernetes, kube create, because if I kubectl create, uh, you basically see that I can use this command to create a deployment, yeah, from an image, so when I create, if let's say I have like an image and I want to create a deployment, I could just do this, and when you run that, you just created your deployment. Now, what happens when you create a deployment? So number one, uh, when you run a command like that, a few things happen. Uh, a suitable node will be searched for, where an instance of the application can be run. So in this case, we have one available node on this local computer, so that will be used here. But if we had a cluster that had like 10 nodes, so our and a suitable node will be searched for. What algorithm it uses to search, for the whatever, that one I don't know right now, but I know that it will search for the one that is suitable and put an instance there of our application. Now, so the scheduled now that application will run on that node, and the configured cluster to reschedule the instance on a new node when needed. Now, so again, that is what happens. Now, this is like we can create a deployment like this, but most commonly we will be creating it from a file. Yeah. So in a file like this, all right. So this is where we'll use this command kubectl apply -f, and then we specify the file. So in my case, I would do kubectl apply, then if I wanted to, then I would execute that. But I already did. And so if I'm to get and see my deployments, I kubectl get deployments. Boom. So those are my deployments. And so let's take a look at how to update deployments. So we can see in the documentation, if you wanted to update deployments, this is how you do it. All right. Now, let me load all these elements so that we talk about them at once. Now, this is like a complete structure, and I'm coming to are something called a service, and then we will see what that means as well. So this diagram, it kind of completes the entire deployment and cluster, and shows my node pods that I created with my deployment and the services that I have, and I'll try as much to explain. So when I created my deployment, so I have two deployments, the one for my Django backend and the one for the database, as I earlier said. So when I created my Django, my Postgres deployment, so at first I had indicated two replicas. So when when you indicate two replicas, right now I changed it back to one, but here in defining my deployment, I'd indicated two replicas, and it created two pods. Yeah, it created two pods. So these two pods, this is now a replica set. These two pods had different IP addresses, but were all exposing the same port. Yeah, yeah. So this pod, they even had different names, but basically doing the same thing. Yeah. So what we see is that these pods were created and put onto my node. Now, if you see uh, my node, it has my node is called Minikube. Like if I come here and I say if I say kubectl get node, boom, you see that it's called Minikube, and it has some details that we saw earlier. It has a kubelet, it has container runtime, and the container runtime will even show you the Docker version and the kubelet version and the kube proxy. Yeah, so this is my node, and and when I created a deployment, I had my pods created there, and also my backend, deployment, which is this, had one pod, and it created for me basically one. It had one on the replicas, it had one and specified one and created for me one pod and gave it an address of 12.17.0.1. So these are in the same node, and as we can see, uh, the IPs created by these, they all start with the first three figures are the same, and that shows that these are in the same node. Now this node has an internal IP of this, but mainly what we want to see here is what we call a service. Now, but before I get to is what we call a service. So now, if we want to, for example, access our application from the browser, how would we be able to do that? So number one, I could access my pod directly by using a proxy, or I could access it through a service. Yeah, but of course, we are not going to be accessing it using a proxy, but we are going to use a service. Now, there is the best way to do it in deployment. In production is to use ingress, whereby our requests go through ingress, and then ingress directs the traffic to the services. But here we are actually accessing the service directly. So in this, so you can see here we are using the service and accessing the service directly. So how we have some questions on this. So what we see is that this service is accessing this pod. But uh, how does it access this pod? So if you look in our service configuration or in our service um, instructions, we have a target port 900, and this is what tells the service uh, which port um, it should reach out or should access direct the traffic to on the pods. And our port 8000 is what is exposed by the service, but the target port is the port of the um, of the of the pod which this service will be accessing. The same thing here. Uh, this port, um, this service is having a target port of 5432 and also exposing um, the service is exposing this port, but the port exposed by the pod, if the service is trying to reach to the pod, it will reach through to the pod through this port. Yeah. Okay. All right. And also when we are specifying when we are doing our deployment for this database pod or container, we specified that it will be exposing 4532, and that is the port that will be exposed by the container, yeah, within the pod. Yeah, so let's go ahead now. But if we are to define what a service is in brief, it is an abstract way to expose an application running on a set of pods as a network service. Yeah. So we don't want to, every IP that is given to the pods can be accessed through the cluster network internally, but not from the outside. So the service gives us like external access from like the browser and all that. And why do we need a service? Every time we create a pod, every time a pod is created, it is assigned an IP address. So if let's say a pod is destroyed and a new one is created, it could have a different IP address. So which means that if we are accessing a pod, let's say, directly in some way, we would have to keep track of, we now have to, the IP address has changed and we have to like check the newly created pod and determine what the IP address is, which won't be reliable in any way. So a service provides for a stable IP address. We just define it within the configuration and say it is exposing, let's say, this port 8000, and that port will not change. It will just be that. And it means we can always access, uh, the service through its IP address and then the port that it exposes. Yeah. It also provides load balancing. So like this pod, this service that has two pods, if one goes down, it will automatically create another one. Another one will be automatically created. And also, when we send traffic, it could send it to any of the pods. Yeah. So that provides some load balancing. And also there is loose coupling. So we do not have to keep track of which container we are sending traffic to or which pod we are sending traffic to. We just, access our service and we know that, yeah, it will reach out to whatever pod that it needs to reach out to. And it allows us to sort of to have communication within and outside the cluster. So each pod, if it is um, accessed through a service, it means pods can communicate with each other internally in the cluster through services, and we also have external access like we have seen. Yeah. And also that's mainly it, and that's the use of services. So let's ask ourselves one question: how does the service know which pods it is managing? Or how does a service know if let's say it has like 20 pods under it? How does it know uh, which pods it should be forwarding, its requests to? You might have like 20 pods and maybe 3 services. How does a particular service know that I should be forwarding my, traffic to this pod? So how it gets to know that is through selector. As you can see here, when we are creating our deployment, we in the metadata we set a label, for the pod, yeah, and we set a label, and now the pods are given these labels during deployment configuration, and the service selects the pods with a certain label. So when this, as we can see here, this spec is what will create our pod, and you can see that it has this label. So when we are creating a service, we use a selector to tell the service which pods it will own or it will manage, and this selector will now go and select all the pods with this label, and then it will know that those are the ones they have to manage. Yeah. So that's how it knows that. And basically what a service does, it uses endpoints to keep track of its member pods. So for example, if I want to know um, if I want to know uh, you know the endpoints for the pods, so I can say kubectl get endpoints. Now I now know that this service has this endpoint that it uses to keep track of its pod. Now, if I say kubectl get pods, now, so what we can see is that we have these 2 pods, one with this IP address and another one with this IP address. But what we see here on the endpoint is that Graphene service has an endpoint, for this node, for this pod, and that endpoint has an IP and the port. So it keeps track of its pods and through the endpoints. So it has these endpoints. So if I add another, let's say if this service was keeping of 2 pods, they would all come here with command, another IP address, and then the port, like that. Yeah. So the port and then the IP and the port. So it keeps track of the pod through the endpoints. Yeah. That is the most important thing. Now, how does the service know the port to forward the requests to? Now, if the pod has multiple ports, i.e., like if it has 2 containers within the pod, if there are 2 containers within the pod, how does the service know which port to forward to? So when we are defining our service or configuration, the target port is what tells which port we will forward our requests to. So in this case, even if this pod had 2 containers, we will be directing it to port 9000, and then that will mean that we will have access to the container that is exposing that port. Yeah. Now, what we should know is that the target port has to match the port on which the container is listening within the pod. So if the container is listening on port 9000, by specifying the target port, it means that we are saying, you know, we are saying that we are going to reach out to that port, to that pod on that port, and therefore we'll be accessing the container on that port. So these two have to match. But for most cases where we have one container, it means that whatever container, whatever port is exposed by that container or available on that pod is what we specify here, and that's how that gets to to happen. Yeah. All right. So now let's look more at the selectors and the labels. So each pod has, what we should know is that we have a deployment. Now a deployment creates a replica set. A replica set might have one or more pods, but in this case where we are looking at it having, let's say, this would be like our replica set with like three replicas, and we'll create 3 pods, and these pods, they have a label. So if all these had label A, now when we reach a time for creating our service, and we say app equals A, and um, we are basically selecting the pods and saying, okay, these are the pods that we are interested in, and all those pods will now belong to this service, or will be managed by uh, or will be members of this service. Yeah. All right. Are there some commands that we can execute to learn more about the pod, how we can use app labels, but basically to show this into practice, for example, I will my config has I'm creating a pod with this label. So I will try and execute this command and say, give me pods that have this label. And you can see it returns that. If I want the ones in Postgres deployment, we have this label. So if I do the same thing, and you see it returns the pod with a label that I've specified. Now the same thing with the services, as long as we specify the label, it will always return that specific one. And then we can also apply new labels, by executing commands like this. Yeah, basically. So more on services, we can delete a service that we can use a label as a filter to determine which services to delete. So it means this will delete a service that that matches this label, and and um, and yeah, that's it. The other more commands we can learn about, but I will leave those and proceed to service types. Now, most importantly, when creating services, there are service types that we need to know about. So one is called the cluster IP, then another one is called the node port, and the load balancer. So what we need to know about the cluster IP, so when we specifying the type, we under the spec there is type, so we specify that type. So cluster IP basically exposes the service on an internal IP in the cluster. This is the default one, and it means that um, if our cluster is of type cluster IP, it means that that service is only accessible within the cluster, and no external traffic can directly address the cluster IP service. Yeah. So if we do this, it means that all our services are going to just communicate within the cluster itself. But if we want to access the cluster outside, uh, there is another type of service we can use called a node port. So what a node port does, it basically exposes the service on the same port, of each selected node in the cluster using NAT. Now, what is happening here is that we create a service that is accessible on a static port on the worker node on the cluster. So we can have external traffic, e.g., from the browser, and accessing our service through a static port. So and that port will be basically the port that is exposed by our node. Yeah. And we have ranges of node ports from 3,000 to 30,000 to 32,767. So it means all nodes ports, all node ports will be in that range. Now this is not secure, as these are static ports, and we are basically opening access to worker nodes, and it means that anyone who has who knows the ports that you have opened can actually have access. Now there is, aside from these, we can see some documentation here showing giving more details um, on node port and load balancer. But the load balancer one, it allows us to, it makes a service become accessible to, externally through a cloud provider's load balancer functionality. So the load balancer service is an extension of the node port service, but it basically allows, it is the way that could be used, for example, in production. Yeah. So the way it would work in production is that one could use a load balancer or use ingress. Now, ingress is something we'll talk about later in another video, but actually in my locally here, I am actually deploying using I'm using uh, I'm using a load balancer, but Minikube has a way to use a load balancer by using a Minikube tunnel. So if I say Minikube tunnel, it allows me to, this is already what I did here, it allows me to use a load balancer locally, and that means that I can basically say on my configuration, I specified it as a load balancer, but because locally there would be no load balancer, Minikube has a way to do that through tunnel. So that's basically what I used. Yeah. Yeah. So that's basically it. Now, service communication are, we have two services in our instance, and the Django. So we have the Django backend service and the database service. How is the Django backend able to communicate with the what? With the database? So within my settings in the application, basically here within my settings, I once we have a service, it means that even a container can actually send traffic to that service as long as you know the service name and the port that is being exposed by that service. So since Postgres database is being exposed as a service, okay, and it is exposing this port, I can actually, within my Django application, I can set the host to Django, to the Postgres service and the port, and that will now give me access So to the database service. Uh, because with that it means that I'll be able to access the container that that is within that is running the Postgres database. Yeah. So that's how that happens. And within any pod, that kind of this allows internal and external communication as we talked about. So which means that even internally, pods or containers can actually send traffic to another service. As long as you know the service and service name. Yeah. Now, let's just have a brief look at ingress. So right now we are accessing our application through a service, but what would happen, let's say in production, is that ingress would expose HTTP and HTTP routes from outside of the cluster to services within the cluster. So we would have like ingress, managed load balancer receiving requests from a client and then routing them to the services. Now, this is something we'll do later on and see how that works in detail. All right. So there are some good resources here, and I thought I would link this. Um, there is oh no. S- s- So TechWorld Nana explains very well about services, and this would be a nice video to check out basically. And all her other videos are also nice. I would recommend people checking them out. Then there is also this blog I kind of found out about. It has like deploying from A to Z. I think it also be nice to go through and basically have more insight. But I'll quickly go through this. What I'm going to do is I'm going to delete my deployments. Now, I will do that very quickly. I want to delete my deployments and recreate them. Okay, so kubectl ctl uh, get deployment. So I want to delete this deployment. And so the other one is the Postgres deployment. So once I deploy my deployment, it also like deletes the pods. So if I say kubectl get pod, I don't see anything now because they have been deleted. And sorry, if now I even come back to my okay, if now I come back to deployments here, I see nothing. I can also delete the services, but let me do that through here so that we move fast. But basically the same delete command can be applied for services. I'll also delete this secret that we have. And I can't delete the node, so I'll also delete everything that we have created and recreate it. All right, so which means that right now we basically don't have anything, but I think our container is our image is still running. So if I say and by the way we can if I can see my Docker images. And the way to make sure that I'm connecting to the Docker service inside of Kubernetes, I have to do this. So once I do that, it means that I'm using the Docker environment within Minikube. This will now not be what I'm using within on my PC here. So if I say Docker image, I I am able to see that I have this image. So I also delete this image. All right, so I've also deleted it. So which means right now, so if I am to confirm, uh, now I don't have any running containers apart from the one for the dashboard and all that, yeah. But for my backend and my database, I don't have any running container. All right. So which means we are at 0 right now. So what I'm going to do is, number one, I'm going to build an image from my Docker file, okay? And so Docker build. Again here, since I am using the Docker environment in my Minikube, it means it will build it into Kubernetes, into the Docker service, into the container runtime of Kubernetes, not the one on my PC. Okay, so I will build with a tag that I want to say latest. And by the way, before I do that, if I say image ls, you can see that I now don't have that image. These are other images. So I want to show that once I will create a Docker build -t fed hr oh sorry. So I want to build that image. So since my Docker file is within this directory, I'll just put a dot. So we'll wait for that to build and finish. Now, the reason I'm building that first is because when I come to executing my backend deployment, I am actually relying on that image. So if I don't create it first, then it won't be found. Yeah. And I have an image pull policy which says it will try to pull if the image is not present. So I want it to be present so that there will be no pulling that is attempted, because I've not configured any container registry. So now if I'm to again check, I'll see that I have an image here. Perfect. That's okay. So now I need to run my Postgres deployment. So I would say kubectl apply fed hr Postgres deployment. So I want to that. So what this one will basically do, it will create this secret, this persistent volume, and this persistent volume claim, and then it will create this deployment. I will have another video where I explain what happens here, but this secret basically keeps the information that we don't want to expose, yeah. So we can do that, and then this is about volumes. I'll explain that in detail, but then here we specify our metadata. This will be the name of our deployment, and then this is our label, the replicas. We want it to create 1. If we say 2, it will create 2. If we say 3, it will create 3. And then this is where now we specify what our containers will be like, the containers that we run inside our pods. This specifies how our pods will be created. So this will be the name of the container. And then for this Postgres, we are actually using the image, a standard image. This will be pulled from Docker Hub. And then these are some settings for the database, and then the ports that we want to expose on the container that is created, and then volume mounts, and then we have the service that is created. It will be exposing this port, and it will be targeting this port on the container that is created inside the pod. So let's run that. So all that is created. So if now I say do, sorry, kubectl get deployment. So if I say that, you see now we have that one deployment. And even if I come here, you can see that I have this deployment and all checks out. I have the service, I have the pod, looks good. So I will also create the deployment for okay. Okay, so I want to do the same. So kubectl apply -f fed-hr. The reason I create the database first is because I know that my application is dependent on the database, so I'd rather create that first, graphene. So this will also create the deployment for graphene, and then the service for our, yeah. So if we see, what we see is now that our service, can be accessed through this. Perfect. So our service was exposing port 1000, so that's why we have 1000 here. But so if we say Minikube service, so let's say kubectl get service, Minikube service. So you can basically see we see some difference here. This is the IP address. So if I'm to do something here, kubectl describe service that. So what we see is that this service has an IP address of this and is exposing port 8000. So this is the IP and the port exposed by that service. But the node that it is connecting to, this is the IP address of that node. If I say kubectl get node, so I would basically see that, okay, kubectl describe node minikube. So if I'm to check on the IP address of this one, we see that our node has an internal IP address of this, and the port that is being exposed, that the port, the port exposed by that node is, if you see, so is port 3 is port 31558. So it means that if we since the service is connecting to that node, we can also access our application through that node and then the port of the node. This is the node port, and then this is the port exposed by our service. Yeah. So so there are two ways of accessing this, either using the external IP and 8000, or the node port and then this IP of the node exposed by the node port by the node. All right, so that's it. And if we wanted to I earlier showed how we can connect to the container and run migrations and all that. So I won't repeat this, but basically this is what we have. So thank you so much. I'll be doing another video on Ingress and the one that explains the YAML and each command that we put there. Right. Thank you so much.